Hello students, welcome to the chemistry class. So as you can see on your screens, today we are discussing a very important chapter for JEE Mains in Advance, and this is called unit number 1, unit 1, and the name of this unit is some basic concepts of chemistry. It is a very important chapter for JEE syllabus in terms of concepts and numericals. Okay. So without wasting any time, let's begin. In this entire lecture, we'll follow uh, uh, this kind of flow chart. Okay, let me show you the complete flow chart. We'll discuss it later. Yeah. So this is the flow chart which we have to follow in this entire lecture. You can see here everything is given in this flow chart. The name of chapter is given, that is some basic concept of chemistry. I'll zoom it to you during the explanation. We have some important subtopics here: classification, matter, importance, physical quantities, stoichiometry, empirical formula, molecular formula, right? Limiting reagent, mole fraction, the difference between mixture and pure substance, etc. Right? So we'll discuss all of them in this lecture. So let's begin. Okay, let me zoom it to you. Okay, now first of all, we are starting with the definition of matter. What matter is? So as you can see here, it is already written here. Matter is equals to anything which occupies space. So listen, whenever we have to talk about the matter, we have to uh, memorize these two facts. Number one, anything which occupies space, and number two, anything having some mass, right? Suppose I have this pen. Okay, this pen has some mass, right? And whenever I used to put on any surface, it occupies some of the space of that surface, right? So anything which occupies space and have some mass is called matter. And this is very simple definition of matter. Okay, now matter can be classified into several parts, like in the flowchart is expressing that: solid, liquid and gas. If particles of any matter are compactly packed, or we can say all the particles are close together, particles are held very close to each other in an orderly fashion with no freedom of movement. If particles are not freely moving and very close to each other, are called solid, like your NaCl, rock, your soil, uh, silica, etc. Right? So this is the solid. If we talk about the liquid, particles are close and can move around. Particles are not compactly close, but they are close to each other. They have interaction with each other, but they can move freely in the surface or in the environment. For example, water. Okay, if you spill the water, you can see the movement of particles, right? So this is the example of liquid. If we talk about the gas, particles are far apart and their movement is easy and fast. Whenever we talk about the gas, two particles of gases do not interact with each other. They will not interact with each other, and all the particles are completely random. They can move freely in the atmosphere. Your atmosphere is a very good example of gas. Every gas is present in the atmosphere, that like oxygen, nitrogen, carbon dioxide, etc. Okay, so these are the very fundamental types of matter. Okay, one very important thing about these matters, these types are: if we talk about the solid, they have definite volume and shape. Their shape is fixed, their volume is fixed. If I am taking a cube of iron, iron is a solid. All the particles of iron are compactly packed with each other, right? So the volume is fixed as well as the shape is fixed. Okay. Similarly, for liquid, their volume is fixed, no doubt in there, but their shape is not fixed. For example, suppose I have this water bottle, right? We have this water. Now water becomes cylindrical in this water, in this bottle, because bottle is also cylindrical, right? But whenever, sorry, whenever I use this water in a container, water will take shape of that container. Okay, so the volume of water is fixed, like 1 liter, 2 liter, this is the volume, it is fixed, but the shape will not be fixed. And for gases, their volume and shape will not be fixed, they are undefined, and we cannot see the particles of gases also. Okay, now next one is a very simple topic, that is properties of matter. As you can see on screens, properties of matter. Whenever we talk about the matter, we have to explain its two kind of properties, that is physical properties and chemical properties. In physical properties, we have to measure or observe the matter without changing the identity or composition, like color, odor, uh, uh, we can say hardness, strength. Okay, so we are not compromising with the composition of that matter, we have to observe its nature only, externally. Okay, but in chemical properties, we have to observe the reactions, or we have to observe the change of composition, change of molecular formula, change of number of atoms or particles during a interaction, during a chemical interaction or chemical reaction. So as written in the flowchart, properties measured, observed when a chemical reactions occurred, like acidity, basicity, combustibility, etc. Okay, so if you are not changing the formula of any matter or molecule, it will be physical properties. But during some activities, if you are able to change the properties, if you are able to change the composition, it should be your chemical properties. Okay, now the next topic is how can we measure the matter. So we have several points here to understand the measurement of any matter. Number one, we have to measure any kind of matter in SI system only. SI system stands for international system, right? Like length, meter, kg, pressure is 1 atm, temperature is Kelvin. This is the SI system, right? Number two, mass is the amount of matter present in a substance. Every substance contains very small or sufficient quantity of mass, sufficient amount of mass. Okay, so every matter contains mass, there is no exception. Number three, weight is the force exerted by gravity on an object. Suppose I am right now 75 or 80 kgs of my weight on the earth. Why? Because earth is applying that amount of force on me, right? So weight is the force exerted by gravity on the on the object. If I move on the moon, move on the surface of moon, my weight will reduce, because the gravitational force of moon is 1/6 of earth, gravitational force of earth, right? So suppose I have weight of 60 kg. Suppose someone has weight of 60 kg, so 60 upon 1 by 6, it should be 10 kg. So a man having 60 kg of weight on earth will be 10 kg, will face 10 kg of weight on moon. Okay, so the weight is completely depends on the gravitational force of any planet. Number 4, uncertainty of measurement, range of possible values within which the true value of measurement lies. Yes, suppose we are calculating some of the measurements or calculations during the chemical reaction, chemical properties, then the possible values which we are studying, it may be uncertain. Uncertain values are, suppose some values are 1.2352. Okay, I can write it as 1.2. Okay, so I have removed some of the minute values to obtain the approximate values. Okay, so whenever we whenever we do calculations of during the chemical reactions, chemical observations. Okay, so we have to do approximation of values. So this is called uncertainty of measurement, because we are not doing the fixed uh, uh, calculation in that area, right? Next is significant figures. Now, significant figures are meaningful digits know with certainty. Now, what is significant figure? Suppose I'm taking any, I'm performing any calculation, and in that calculation, I have obtained 1.0029 and another value is 0.0029. So the significant value for this digit will be 5, but the significant figure for this value should be 2. Now why? Because significant figure is completely depends on the position of zeros. If zeros are present between the integers like 1, 2, 3, 4, you know that, so it should be complete significant value like the first example 5 number. And if zeros are present before the digits, before the integers, then it should be neglected and the significant value should be the integer like 2. Okay. Now other one is precision and accuracy. Now precision and accuracy is very simple. As you can see on the screen, precisions are closeness of various measurement of same quantity, and accuracy is agreement of a particular value to true value of results. Suppose I have done one of the reaction, A plus B gives out C, and I have obtained 6.229, or we can say 6.5, sorry, 6.48529 gram of C. Suppose I am assuming this. So after the reaction of A and B, I have obtained 6.48529 gram of C, but this is an accurate value. I'm writing on the screen, but I don't have time to write this kind of huge value, so I am doing approximation like 6.5. As you can see here, 6.5 is close enough to the 6.48529. So 6.48529 will be your accurate value and 6.5 should be your approximate or precise value. Okay. So after this, let's move on to the physical quantities. During some numericals, during the solving of numericals, we have to use some physical quantities like length, mass, time, electrical current, thermodynamic, temperature, amount of substance, and luminous intensity. And after and during these during the use of these physical quantities, we have to use some units, the prescribed units according to the SI system. For length, we have to use meter, 10 meter, 20 meter. For mass, we have to use kgs, 10 kg, 20 kg, etc. like. Okay, so you have to learn all the units because these units were asked many times in the previous year. If you can see these type of questions in previous year papers, so you have to remember this. Okay, like the unit of luminous intensity should be candela. Okay, the unit of amount of substance is mole. So these quantities should be remembered from your side, and these are very simple. If you repeat them 5 to 6 times, you will be able to recall them easily on in the examination or in any question solving paper. Now after that, let's move on to the classification. We have completed the matter, we have completed physical quantities. Now we are completing classification. On the basis of some properties, matter is classified into two parts. Number one, mixture. Now what is mixture? Mixture is mixing of two or more components, right? So two or more substances present in any ratio like air and tea. Okay, so if you are mixing anything but the components must be more than one, they might be 2, they might be 3, 4, 5, whatever the ratio should be. Ratio is not fixed, but the mixing of components should be different, right? So mixtures are completely depends on the mixing of two different substances, more than one different substances, right? And on the basis of mixing, we can divide mixtures into two parts, homogeneous and heterogeneous. Homogeneous state should be similar, state or phase we can say it should be similar, like water is mixing with glucose, so both are liquids, so homogeneous mixture, uniform composition. Okay, and heterogeneous mixture, their composition should be non-uniform, like you are mixing sugar in water, the sugar is solid and water is your liquid. liquid. So phases are different or states are different, so it should be heterogeneous. Like, second type is pure substance. What is pure substance? In pure substances, particles or atoms are completely similar of that particular substance. Suppose I am taking the substance of iron. I am taking a cube of iron. So in that iron cube, I will be observe only iron particles, Fe particles. So this is called pure substance. Okay. So we can say fixed composition of particles. Okay, like copper, silver. The examples are given here. Okay. Now, pure substances are again classified into two categories: elements and compounds. In elements, only one type of particles are there, sodium, copper, etc. Right? But in compounds, two or more atoms are given in different elements, like H2O, NH3. In H2O, we can say that one oxygen atom is attached with two hydrogen atom. The ratio is fixed. It means for the formation of H2O, we need two hydrogens with one oxygen only. We cannot form H2O, or we cannot observe the H2O where hydrogen is 3, oxygen is 1, or oxygen is 2, hydrogen is 1. Not possible. Okay, so for the formation of H2O, we have to take two hydrogens along with one oxygen. Okay. Now we have some laws here. Law of conservation of mass. This law was firstly proposed by Anthony Lavoisier. Okay, and according to this law, matter can neither be created nor be destroyed. It should be conserved. Suppose you are reacting 10 gram of A and 10 gram of B. The product should be 20 gram. This is called conservation of mass or mass law. Okay. Law of definite proportion. A given compound always contains exactly the same proportion of element. It was given by Joseph Proust. Joseph Proust said, if we are taking the example of H2O, whatever the process is, if you are making H2O, the ratio should be 2:18. Okay, you are obtaining the H2O from river, or you are obtaining from the ocean or lake. Whatever the case is, the ratio of H2O should be 2:18. So this is the law of definite proportion. Now, law of multiple proportion. If two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of other element are in ratio of small whole number. It was given by Dalton. It's a very simple thing. You can memorize it. Now, Gay-Lussac's law of gaseous volume. When gases combined or all produced in chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. This is also simple. Avogadro's law: equal volume of gases at the same temperature and pressure should contain equal number of molecules. It is a very simple thing. Dalton's atomic law. Dalton said that each matter, or we can say every matter, is made by very small particles, and these particles called atom, and atoms are invisible. Okay, and 4 points are there. Matter consists of invisible atoms. We know that all the atoms of a given elements have their identical properties, including identical masses. This is again very a common point. Compounds are formed when atoms of different elements combined in a fixed rate. It is again a simple thing. Atoms are neither created nor be destroyed in chemical reaction. It is also a simple thing. Okay. So all these 4 points are given by Dalton to explain that every matter is made by very tiny, very small particles, very invisible particles, indivisible particles. Okay, which is called atom. So I hope all these explanations is helping you in the preparation. So please watch it carefully and listen it carefully, and please do questions of previous year apart from your NCERT questions, right, to learn all these things very effectively. Okay, now we have let's move on to the this section. Yeah. What is the meaning of atomic mass unit, AMU? Scientists said that every substance present on earth have some mass. So if we are talking about an atom, so atom also contains small amount of mass, which is called atomic mass. And if we are calculating atomic mass, then we should use the unit atomic mass unit, AMU. Okay, so the definition is already written: a mass exactly equal to 1/12. Let me show you completely. Yeah, the mass exactly equal to 1/12 the mass of one carbon 12 atom. Suppose we have carbon 12 atom, suppose x, so x into 1 by 12, it should be your equal to 1 AMU. Okay, so very simple definition you have to remember from your side. Now what is molecular mass? Molecular mass, when atoms combine together, okay, when atoms combine together, they will create a molecule. So if we are discussing about the atomic mass, that is mass of one atom, it should be mass of one molecule made by same or different atoms. Okay, so definition is already written. Some of atomic masses of the elements present in a molecule. Okay, very simple thing. Suppose we have H2O. We know that H2O is made by 2 hydrogen and 1 oxygen. So the atomic mass of hydrogen is 1, so 2 into 1 plus atomic mass of oxygen is 16. So 1 into 16. So the result is 18. So what we have done, we have uh, uh, did addition of atomic masses of all the atoms present in a molecule, which is called molecular mass. Now what is formula mass? Formula mass is generally used for the ionic molecules or ionic compounds, we can say. Suppose NaCl, KCl, MgCl2, etc. Now the definition is, so some of the atomic weights of atoms in a molecules, 1 mole is the amount of a substance that contains as many particles entities as their atoms, exactly 12 gram of the 12C isotope. Okay, so generally we are comparing the formula mass with any compound with 12 gram of C12 isotope of carbon. Okay, so these definitions are very simple, you have to remember it, there is no option. Okay, now what is molar mass? If we are talking about the molecular mass, the molecular mass is mass of one molecule. But if we are using Avogadro's number, the Avogadro number is 1 Na, please remember this value, 6.023 into 10 to the power 23. Okay, so if we are taking molecule in that number, this is a very huge number. Okay, suppose we are taking one oxygen, it should be 16 AMU or U according to some books. But if we are using one Na oxygen, it should be 16 gram, and this 16 gram is called molar mass. So we can say that molecular mass or atomic mass in terms of 1 mole, because one Avogadro number is always equal to 1 mole. 1 mole is equal to 1 Avogadro number. This is very important, you should remember that. Okay, so molecular mass or atomic mass of any substance or any atom or any matter, any compound in terms of 1 mole, it should be called molecular mass, sorry, it's called be molar mass. Okay, so molar mass of 1 mole of substance in grams written in the screen. Now there are some methods to calculate the concentration or mass or we can say general terms, like we have mass percentage, we have molarity, and we have molality. Okay, mass percentage can be calculated as mass of solute, given mass of solute upon given mass of solution into 100. Okay, suppose we have uh, 10 gram, suppose we have 10 gram NaOH into 90 gram of water H2O. So what should be the mass percentage? It should be equal to 10 gram upon 90 plus 10 into 100, answer should be 10%. Okay, it's a very simple thing. Now molarity is defined as total number of moles present. Remember, total number of moles present in 1 liter of aqueous solution. Total number of moles present of solute in 1 liter of aqueous solution. So the formula should be number of moles of solute upon volume of solution in liters. Okay, now molarity, molality, The symbol of molarity is capital M and the symbol of molality is small m. Now what is the difference between both of them? Both are generally simple things, but in molarity we have to take volume in liters, and in molality we have to take mass of solvent in kg. So the formula should be number of moles of solute upon mass of solvent, it should be in kg. So these are very simple things. This chapter is very simple, but you have to solve questions as much as you can. So it should be simpler for you in the examination. Now next one, yeah, stoichiometry. What stoichiometry is? Stoichiometry defines the what say. Suppose we are performing a reaction. Suppose I am writing here. We are performing a reaction. Nitrogen is reacting with hydrogen and releasing ammonia. Okay, but in class 10th you have read definitely balancing of equations. And why balancing is required? With the help of balancing we can observe the exact number of molecules or atoms participating in the reaction to form a product. Okay, so stoichiometry tells about the balancing, or we can say exact quantity of reactant required or necessary for the formation of product. Okay, so to balance this equation I am putting here 3 before the H2 and 2 before the 2NH3. Now this reaction is completely balanced. This reaction is completely balanced. Yeah, if we want to perform stoichiometry, I have to write the molecular mass of each molecule in this reaction. So the molecular mass of nitrogen is 28 gram, molecular mass of 3H2 is 6 gram, and molecular mass of ammonia, that is 34 gram. Right? Now if I want to set up a factory or industry of ammonia, I know that if I react 28 gram of nitrogen with 6 gram of hydrogen, I'll definitely get 34 gram of what? Ammonia. Now, with the help of this knowledge, I can increase the production. How? If I multiply it with 100, so I can say that 2800 gram is required to 6 gram of hydrogen, 2800 gram of nitrogen is required to react with 600 gram of hydrogen. It will produce 3400 gram of what? Ammonia. Now I have converted gram into kg because 3400 gram is equal to 3.4 kgs. Correct? So with the help of the knowledge of stoichiometry, we can set up a factory or industry, or this method is used in this industry to calculate the enhancement of production. Okay, in kgs, tons, quintals. Okay, so stoichiometry is very important, in which we have to use some balancing methods to calculate the amount of product with the help of fixed amount of reactants. Okay, to balance the chemical reaction, 5 steps are prescribed in the chemistry concepts. Number 1, write correct formula of reactant and products. Balance number of C atoms firstly, then balance number of hydrogen atoms, then balance number of oxygen atoms, and verify the number of atoms in each of this element. Right? So we can say that whenever LHS equal to RHS, your reaction should be reaction seems to be balanced. Okay, you can write. You can see here. 28 plus 6 equal to 34 gram, and this 34 gram to 34 equal to 34. We can say that this reaction is completely balanced. So the main function of stoichiometry is to balance a reaction to enhancement of production of product during a chemical reaction, obviously. Second thing in stoichiometry, it deals with the calculation of masses of the products and reactants involved in the reaction. I have told you earlier, so no need to discuss further. Now next thing is empirical formula and molecular formula. So I'll explain this point in a very simple example. Suppose I'm talking about the glucose. So the formula of glucose is, what is the formula of glucose? That is C6H12O6. Carbon, number of carbon is 6, number of hydrogen is 12, and number of oxygen is again 6. Okay, but if I divide this formula, if I divide this formula with 6, I'll get CH2O. Okay, so if any compound is given and you are explaining the exact number of atoms in those compounds, in that compound, it should be your molecular formula. But if you are simplifying that molecular formula with respect to simple ratios of atoms, it should be your empirical formula. Okay, so molecular formula describes the exact number of atoms in a molecule, but empirical formula defines the simplest form of any molecular formula. Okay, so as written in the flowchart, molecular formula shows the exact number of, see here, so shows exact number of different types of atoms present in a molecule of a compound, and for empirical formula it is written that simplest number, ratio of various atoms present in a compound, in the given compound, we can say. Okay, so empirical formula, molecular formulas are simple, no need to worry to remember these points. Molecular formula tells about the exact number of atoms in a molecule, but empirical formula explains the simplest ratio or simplest form of that molecular formula. Okay, two empirical formulas may be similar, but two molecular formula will not be similar at any cost. Okay, now how can we define the empirical and molecular formula? 5 steps are prescribed here. Step 1, conversion of mass percent to gram, convert into number of moles of each element, divide the mole value obtained above by smallest number, write empirical formula by mentioning the number of after writing the symbols of respective elements, writing molecular formula. And in step 5 is also categorized into 3 parts. Determine empirical formula mass at the atomic mass of various atoms present in the empirical formula. Divide molar mass by empirical formula mass to get the value of n. Multiply empirical formula by n obtained above. So this is a simple method which you have to use to calculate the empirical formula and molecular formula of any compound. Okay. So let's move on to the next topic. Now before moving the next topic, I'll give you some example of empirical formula. How can we calculate it? Suppose a compound X is given. Okay, X is made by carbon and hydrogen. The percentage of carbon is, suppose, 40%, and percentage of hydrogen is 60% for completing the 100%. Okay, now first of all, percentages are given, then we have to convert these percentage into grams. So 40 grams should be converted into 40 gram, and 60% converted into 60 gram. So what we have to do, remove the percentage symbol and add the gram symbol. After that, calculate the moles of carbon and moles of hydrogen. And how can we calculate moles? To calculate moles, you have to divide the given mass upon the the atomic mass of any of that respective atom. So given mass is 40 for carbon and atomic mass of carbon is 12, and for hydrogen 60 upon 1. So after the calculation of moles, you have to calculate the final value, and after the calculating final value, we can easily calculate the empirical formula. Okay, so these are very simple things, like if you divide this thing, 3.12 is 36, 4 is remaining 0, 3.3, and this should be 60. Okay, so 3.3 divided by 3.3 equal to 1, and 60 divided by 3.3 equal to, you can calculate from your side. Okay, so the obtained final value should be your empirical formula of the given compound X. So I have explained in a very short manner, and the detailed steps are written here. Okay, and now what is the relation between molecular formula and empirical formula? So n is equals to mass of empirical formula, sorry, mass of molecular formula upon mass of empirical formula. So please remember these some formulas which is very important for the JEE syllabus. Okay. Now limiting reagent. What is limiting reagent? Limiting reagent defines the rate of a reaction. Suppose I am reacting CH4 with O2, and after the reaction I am getting CO2 gas along with H2O. This is a simple reaction, but this reaction is not balanced, so I am balancing it. So uh, C1, so 2, 2, 3. So I am writing here 4. 2 to the 4, 2 to the 4. Yeah. So this reaction is balanced now. Now you can see here 1 mole of CH4 is reacting with 2 moles of oxygen. So on reactant side, for calculating the limiting reagent, we have to observe the reactant side only. Remember that we don't need to observe the product side, completely neglect the product side. We don't have to do that. We don't have to observe that, right? So for limiting reagent, we have to focus on the reactant side, and on reactant side, we have to observe which reactant has very less moles. Reactants having very less mole will be your limiting reagent. So in this reaction we have only 1 mole of CH4, so CH4 will be your limiting reagent. Now what is the function of limiting reagent? If CH4 consumed completely, the reaction will stop at the same time. Okay, so with the help of limiting reagent we can easily calculate, or we can easily conclude uh, uh, for any reaction when it will be completed and how much product it will produce after the complete consumption. Okay, now the definition is written: reactant which gets consumed and limits the amount of products formed. Okay, so I explained you earlier. This is a very simple line you should remember from your side. Now mole fraction. Sorry, what is mole fraction? Suppose you have mixture of gases. I'm rubbing this, I need a space. Suppose I have a container, I have a sealed container, right? I have filled this container with two kind of gases, big dots and small dots representing two different gases. Two gases are filled in a container, in a sealed pack container, and my teacher or someone told me that calculate the mole fraction or define the mole fraction on the basis of these two gases, gas uh, gas A and gas B. Okay, now to calculate mole fraction I need moles of A as well as moles of B. Okay, so we can calculate the mole fraction of individual component if you have the mixture of gases, right? So the symbol of mole fraction is X, or sometimes we can say it this chi, chi, chi. This is not chi, this is not chai, this is called chi. Okay. So if I want to calculate a chi A and chi B, so mole fraction defined as moles, amount of moles upon total moles, amount of moles of total moles, amount of moles of a respective substance upon total moles. So if I want to calculate the mole fraction of A, I need a moles of A upon total moles, moles of A plus moles of B. Similarly, if I want to calculate the mole fraction of B, I need total moles of B upon total moles of A and B. So after this division, I can easily obtain the mole fraction of any gas. Okay, so the formula is written here, you can remember from your side. And one more thing, mole fraction is unitless. This is a unitless value, don't need to put any kind of unit after the calculation of value. Okay, so we have completed almost everything. Now next stoichiometry is completed. Yeah, importance of chemistry. Now, importance of chemistry is a very subjective question, because the uses and importance of chemistry is very vast. We cannot live without chemistry. We can say it's a very emotional statement, but it's true. We cannot live without chemistry. After the woke up in the morning and before the sleep on the bed in the night, we are completely connected with chemistry, completely. Okay, almost 100%. So there are three importance are written here. In meeting human needs, food, healthcare products and other products required for improvement quality life. Food is all every food has some particles, atoms, so it's chemistry. In diverse areas such as weather patterns, functioning of brain, an operator of a computer, in chemical industries. Okay, so everything is connected with chemistry. Suppose we are using this digital system like laptop, computer, phones. These are made by motherboards, and every motherboard needs plastic, metals. Plastic is made by carbon. Okay, metals, you know that metals, many metals are there: gold, silver, copper, platinum. Okay, so everything we are using today, including water, is chemistry. So importance of chemistry is very, we can say, essential for today's life. Without chemistry we cannot survive a single day. Okay, so we have completed all each and every point of this flow chart. Okay, now I need to practice some questions here. So I hope this flow chart is beneficial for you, and I have explained in a very well manner. Let's practice one or two questions in terms of molarity and molality. Okay, so let me create some space here. Yeah, so let's practice some questions. Now question number 1, calculate capital M, means molarity. Calculate capital M molarity if 40 gram NaOH dissolved in 1 liter solution. So this is a question. We have to calculate molarity. M stands for molarity. Molarity. Okay. So how can we solve this question? Please pause the video and do with yourself, because we have uh, studied the formula already. Yeah, this is the formula of molarity. Number of moles of solute upon volume of solution, liters. Okay. Okay. I hope you have solved the question. Let me tell you the answer. Now, for calculating molarity, we know that molarity is equal to moles upon volume in liters. Okay, so first of all, I have to calculate the moles. The symbol of mole is N. Why I am writing N again and again? Because N stands for moles. So moles of NaOH should be written as given weight upon molecular weight. So given weight of NaOH is 40 gram. You know that. And what is the molecular weight of NaOH? It's again 40 gram. So mole should be 1. Now second thing, do we have the volume? Yes, we have the volume in liters also, that is 1 liter. Okay, now the answer should be M is equals to N by V. 1 upon 1 is equals to 1. This is the answer. Okay, so questions are very simple if you practice a lot. Yes, you have to practice a lot. from your NCERT book, from your previous year papers set, you can easily qualify the examination without any hesitation. Okay, now let's practice question number 2. These are very important questions, and you have to practice as much as you can. Now, question number 2 is calculate the mass if let's take if C6H12O6 present in 2m aqueous solution and volume is given, that is 1 liter. Now in this question molarity is given. Let me change my pen. Yes, in this question molarity is given, that is 2m. You can pause the video to solve this question. Okay, let me solve it. Molarity is given, that is 2. Volume is given, that is 1 liter. We have to calculate mass in grams. Okay, now we know the formula m is equals to n upon v. Okay, in liters. We don't have the n is equals to w by m. Now we can convert this formula, or we can modify this formula as capital M is equals to W upon M upon V in liter, right? So I can write it as M is equals to W upon M into V. Okay, so M is 2, W is unknown, so W, M stands for molecular mass, so molecular mass of glucose is 180 into volume is 1. So what should be the weight? Weight is equals to 2 into 180 is equals to 360 gram. This is your answer. Okay, so if your concepts are clear and you have practiced more, you can crack any type of question in a very simple manner, in a very less time. I'm explaining you, that's why I'm taking the time. Otherwise these questions are solved in a minute, in a simple 1 minute. Okay, so let's practice one more question from the mole fraction. Okay, so give me some time, I'm creating some space. Yeah, suppose we have a question, 10 gram NaOH dissolved in 100 gram of H2O. Calculate mole fraction. I'm practicing all the questions in subjective manner, but in the JEE examination you know that options are given, so you can match those options, but you have to do in a subjective manner only in the rough book. Okay, now this question belongs from to the mole fraction, where we have dissolved 10 gram of NaOH in 100 gram of water, right? So what we should do, we have to use the formula. Which kind of formula? Which we have read in this lecture. Yeah, mole fraction of A and mole fraction of B. So let me solve you this question. You can try with yourself by pausing this video. Okay, I hope you have solved it. Let me explain you the method. How can we solve this question? Yeah, number 1, first of all I have to calculate the moles of each of the component. I have sodium hydroxide and I have H2O. So first of all I will be calculate the moles of each of the component. For NaOH we have weight 10 gram and the molecular weight of NaOH is 40 gram. So 10 by 40, that is 1 by 4. It should be 0.25 if I am not wrong. For H2O, we have 100 gram of H2O upon 18 is the molecular weight of H2O. So 100 upon 18, it should be equal to 5.55. So I have moles of every component. Now, first of all, mole fraction of NaOH, that is moles of NaOH, that is 0.25 upon total moles 0.25 plus 5.55. You can calculate the answer. The second thing, mole fraction of H2O, moles of H2O 5.55. 5.55, let me, yeah, upon total moles 0.25 plus 5.55. Okay, so this is a simple method. These are simple methods which are completely based on the formula, and in the examinations formula based questions are more than tough questions. Okay, so now you can easily solve, you can add and then divide, and you can obtain the correct answer. Okay. Let me think again. Yeah, one more question from stoichiometry. I hope these questions are beneficial for you. You have to practice a lot from this chapter. This chapter is called mole concept chapter. It is very important for JEE. Okay, so please remember that. Now one more question. I'm changing my pen. Other question is calculate the mass of NH3 if 20 gram N2 is reacting with hydrogen. Okay, so if 20 gram nitrogen reacting with hydrogen, how many hydrogen? I don't know. We have to balance the reaction and we can solve the answer. So if 20 gram nitrogen is given, then how much ammonia we can prepare with the reaction? Okay, so please pause the video and solve the question. Okay, I hope you have solved the question. Now let me solve it. Please tally the process. Answer. First of all, in any kind of stoichiometry question, you have to, please remember that, you have to write down the balance equation. So I'm writing here N2 plus 3H2 gives out 2NH3. Okay, now amount of nitrogen in balance reaction is 28 gram, amount of hydrogen balance reaction is 6 gram, and amount of ammonia in balance reaction is 34 gram. Now we can observe a very common thing here, and what's that? We can say 28 gram nitrogen is producing 34 gram of ammonia. Yes or no? Completely yes. So 1 gram of nitrogen will produce how much of ammonia? 34 divided by 28 gram of ammonia. Okay, so question is asking about only 20 gram. So 20 gram nitrogen will produce how much ammonia? That is 34 upon 28 into 20 gram of ammonia. If you solve this, you can easily obtain the answer. Let me solve this. You can cut this with the table of 2. So 2 ones are 2, 2 fours are 8, 2 tens are 20, 7, 5, 34 into 5, So 34 into 5 upon 7. So 7 4s are 28, 6.6, 4.8. So 4.8 into 5, it should be equal to 4.8 into 5. 4.8 into 5, 0, 4, 24. So 24.0 gram. Okay. So if we are using, remember that if we are using 28 gram of nitrogen, we can obtain 34 gram of ammonia. But if we are using 20 gram of nitrogen, we will obtain 24 gram of ammonia. So 20 gram, according to question, 20 gram nitrogen will produce how much ammonia? The answer should be 24 gram. Okay. So these questions are completely very important, and I am requesting you again, please practice more and more, as much as you can. Please solve 100 questions daily to keep yourself in a practice mode, and with the help of this method you can easily crack any kind of examination, not JEE, any kind of computer examination. Okay. So we have covered all the points of this flow chart. Yes, we have completed. Yeah. One more question I have to tell you. Last question of this session, on the basis of limiting reagent. We don't have solved any questions of limiting reagent. Okay. I have a question for you. Question is, yeah, 20 gram. I'm using the same reaction. 20 gram nitrogen is reacting with 10 gram hydrogen. Calculate limiting reagent. Okay. Now I am giving you a simple trick to calculate all the questions related to limiting reagent. To calculate limiting reagent, always divide moles with stoichiometry coefficient. That's it. How? First of all, write down the reaction. N2 plus 3H2 gives out 2NH3. All the digits comes before the molecules are stoichiometry coefficients. Like for nitrogen is 1, for hydrogen is 3, for ammonia is 2. We have the masses, so please solve the calculate the moles. And moles of N2 should be 20 divided by 28, 20 divided by, sorry, moles is not 28, 14, 20 divided by 14. And moles of hydrogen is 10 divided by 1, it should be 10. And 20, 10, 7, 1.3, so 1.4. So 1.4 is the moles of nitrogen and 10 is the moles of hydrogen. Now how can we calculate the limiting reagent? LR, first of all, 1.4 upon stoichiometry for nitrogen is, stoichiometric coefficient of nitrogen is 1, it should be 1.4. But for hydrogen, 10 divided by 3, so 10 divided by 3 is equals to 3.33. Okay. So after the calculation, reactant having very less amount of LR should be your limiting reagent. So between 1.4 and 3.33, which has very less quantity, that is 1.44, it should be LR. And 1.44 related to nitrogen, so LR should be equal to nitrogen. Okay. So I hope all these things are things were easier for you in this lecture. I have tried to keep all the things simple according to the flow chart. and please read all these pointers in very detailed manner. Practice questions as much as you can, because um, uh, it will be beneficial for you in the examination and in solving of question papers. Okay, so enough for today, guys. Thank you so much. We'll meet in some other lectures. Thank you so much.